Hey guys, I'm Jim, WT1W, and you're watching FEPLabs Radio. Thanks for stopping by. Appreciate it. So, in this video, we're going to ponder the innards of a linear power supply. Full disclosure, not an electrical engineer, not 100% sure what I'm doing. My whole goal is to try and fix this thing without shocking myself and see if I can get it done. The power supply in question is an RS35M-AP, which means it has power poles on the front. It also has 12-volt connection on the back, a couple of bolts. The power supply would come on, and the amp meter, which is on the left side, my left, let's do it this way, would just toggle back and forth. It wouldn't even go full scale. It was just like a few amps, and it would just sit there and oscillate and click. And if I turned it off and back on, then sometimes it would work and sometimes it wouldn't. And the power supply is less than 90 days old. I bought this new online, and I can't remember who I bought it from. It wasn't one of the big three. The power supply was manufactured in 2022. It is brand new. Something's wrong with it. So I've watched a bunch of YouTube videos because, you know, the internet, and they're all basically the same design for the last umpty years on these linear power supplies from Astron. So I thought, well, let's see if I can fix this. So let's jump into it and see how far we got and if I've managed to fix this bad boy. So here we are with the cap out, obviously discharged, and I've got the unit on the desk with a lot of things discombobulated. How did I get here? Well, the power supply started, and I've only had this power supply a couple, 3 months. It's darn near new, and I could have sent it back under warranty. I just didn't want to because it's a hassle shipping this heavy thing, and I thought, you know what, I'm going to try and figure out this on my own. So I watched a lot of online videos. Rob from 741 channel has a great one. There's a couple others, but Rob's was probably, I thought, the most comprehensive. He didn't exactly show the problem I'm seeing. And what I'm seeing here is when you power this on with zero load, the amp gauge over here, the amps gauge, just and ticks. That's all it does. And you get no output or nothing usable and steady. The output just pops up and down. So something's going on with it. I'm not entirely sure what yet because I haven't found any reference to this specific thing I'm seeing. A lot of what I saw online was there's no volts or low volts, but there's some kind of volts. I'm not seeing where the voltage is, you know, doing this up and down thing. So I started tinkering around with this. In the process of doing that, I was using Rob's video as a reference, and I was probing around. And, you know, important safety tip when you're dinking around inside something like this, you should have the little shields on the meter leads so that you don't ground something out you didn't want to. So I did, grounded something out, one of the pass transistors. So I've replaced that. When I started this little project, I bought spare parts. I bought some spare parts of the most commonly replaceable things. So I have a bunch of pass transistors, and I have replacement 723 voltage regulator chips. So I had to replace a pass transistor already. That died in the shorting, the great shorting. So where we're at now, I replaced the regulator chip last night, and it's on the underside of this board, and it is a pain in the butt without desoldering the entire board. And now it doesn't do the thing with the meter and make the ticking sound. I just have no voltage coming out of either back here or on the power pole lugs on the front. So once again, I discharged our giant death cap. What is this thing, like 64,000 microfarads? It holds a grudge for a while. So I discharged that last night, and this morning we're going to take a look at the 723 chip. I have a baggie full of them over here. So I'm going to replace the one that I put in there with a different one, because I think I might have bent a pin or missed a pin or something. It doesn't do the ticking, it just doesn't do anything. After I replaced that again, and these were cheap. This was like, I don't know, $5 for a wad of them. And the same with the pass transistors. It was like $8 for 8 or something. And this particular unit uses 4. I'm going to replace the voltage regulator chip. We're going to plug it back in and power it on, and I'm going to see what kind of voltages I'm getting here, because we have the schematic from Astron, and it lists our expected voltages out here from the LM723 chip. So that's going to be the second thing I do. I think, since I have them, and while I have it open, I may go ahead and replace the other 3 pass transistors at the same time. I have possibly $15 worth of parts I bought. So that's where we are. So on this board, and you can buy replacement parts for almost everything in this case directly from Astron, and they're not expensive from Astron. I could buy a replacement voltage regulator board. And so when I say this board is a pain, you see we have several wires soldered directly to the board, and it's really a pain in the butt to look at the other side. On the back side of this, obviously this is the voltage regulation, but we also have an SCR circuit that is the crowbar piece. And of course, if you go over voltage, then that crowbar engages and shuts down the power. The beauty of the way this circuit works in these power supplies is that if the crowbar does engage because of an overvoltage condition, you just turn the power supply off for 10 seconds and back on, and then it opens up. It's not a destructive crowbar. It's a reusable crowbar, so to speak. Right here, we can adjust our output voltage. All right. So, and then there, of course, is our LM723. So we are going to pop this thing out. And see, to me, it doesn't feel like it ever seated in that socket very well. The legs look fine. I see absolutely no problem with those legs. I wonder if some of them went inside. In any case, we're going to set that guy aside, grab a new one. And the thing about this, and I don't know if it'll show up well on this camera, these legs are slightly bent outward just a little bit. And then what's important on these chips is there is a tiny little notch or divot. There's a little notch, and that's pin 1. So on this particular board, pin 1 is to the outside, and we are going to put a new chip in. All right, so I've replaced the chip, and I found something that could be the problem, and I know this is hard to see. This is the 723 voltage regulator chip. This does not sit in this socket very well. This is loose. It wants to rock back and forth a little more than I think it should. It's not seated super firmly. All the legs are inside on both sides. It's oriented correctly. And it just does not sit in that socket as well as I'd like it to. There's a little bit of a long ways rock and motion. It's not much, but it's there. But the chip is seated in as far as it's going to go. So we're going to go with that. Since I've got it out and got the capacitor out of the way, I'm going to go ahead and replace all these pass transistors as well. I've already replaced the bottom one down here. That's the one I shorted. And, you know, it's possible it could have dorked one of the other ones too. It didn't even power on until I replaced that one. So I don't think it dorked up these other ones. So what we're going to do is we're going to replace some pass transistors. And these are 2N3771 transistors. And this is what they look like. You have the base, collector, and emitter. And on these, this is part of the transistor, the case. So you have these little mica gaskets that go between the bottom of this transistor and the case of the power supply. So what we're going to do is unscrew these things and take them out. Now these are socketed in this power supply, and there's we need to use dielectric grease when we when we put these back on. I'm going to reuse the little mica gasket things unless they look like they're cracked or something. But you unscrew these, and then there's a socket here on the back side, and it's not fastened to the frame either. The only thing that holds this whole assembly together is these two screws on the front. So putting it back in, you got to get it oriented right, and it only goes one way. You'll notice that the distance here is not the same. So when you go to put these in, the holes will have to line up. You got the screw holes for orientation, and that has to line up with the two legs, which are the collector and the emitter. I believe I said that right. And then this is the base. So that's what my next procedure is going to be on this thing. So these are each held in with just a simple Phillips head screw. And as you can see, there's no nut on the back of this. This is a socket right here that holds this thing in. So when I take this loose, the socket is also going to come loose, which means when you put it back in, I've got to hold the socket up there, get the transistor lined up and pushed in, and then kind of hold it still until I can get a screw in it to fasten it down. And of course, I don't want to over tighten it either and crush that little gasket, because that gasket is required to insulate the base of the transistor from the case. The downside to working on this thing, of course, is that it's not light. And then of course, these little legs, the collector and emitter legs, have to line up. And then we push it back into the socket without pushing the socket completely loose from the backside. The one that I shorted out yesterday when I started this little project did not go in quite as easy. What you have not heard now, I've got this one back in the socket, is all the swearing I was doing, trying to get this to go in the socket. It was a little problematic. So now we're going to fasten this guy back in. Woo! All right, that one's done. So I didn't have to take all this off at one time. So now we're going to go grab this bottom one. And then we have to catch the socket, which hopefully hasn't moved around a whole lot. Okay, so we have both of these replaced now. And the next step is to replace this top one over on this side. And then I'm going to put everything back together. What I should probably do, and I don't have my soldering iron here, is I should probably test this bridge rectifier too while I've got this thing apart. And to get to that, I have to unsolder these wires, which are wrapped around these metal bus poles. These are real heavy gauge wire, and these yellow wires are wrapped around that. And I think to test this correctly, I have to disconnect this. This assembly is two rectifier setups, creating a full bridge rectifier. This is on the output of the transformer, and then that feeds in via this red wire to the filter capacitor to smooth everything out. I'm not going to mess with that right now. If this doesn't work, then this is going to require real doctoring. So now we have one more pass transistor to replace. So let's turn this guy around. And I want to harp on something here real quick. This is kind of weird. So design-wise, this is also power output. And you can see it's marked positive and negative. There's no cover on this. And it comes with a couple of spade ring connectors, ring terminal connectors, whatever those are, attached, but there's no cover over these, and these posts are hot. When this thing is turned on, these are hot. So you could hook up your radio back here instead of using the power poles, which is fine, but I would have thought they would have included covers or put a binding post there, something to insulate these a little bit from random touching. And then also on these transistors, on every one of these, we don't want this can, this outside can, to contact the frame, because you will short out the transistor. And these are hot and don't need to touch the ground. Kind of a strange design. They've been doing it that way forever. I still think it's strange. Now, I'm not an electrical engineer. I'm just a knucklehead on YouTube who plays radio, but I still think that's a weird, weird design. So this is our last one to swap out here. And let's get that done. And then let's move on and button this thing back up. So let's put this rascal back in. Oh, Bob's your uncle. That was too easy. All right, there's all 4 pass transistors replaced. So the next thing we're going to do is we're going to put the filter capacitor back in, which is what I lovingly refer to as the death capacitor. And this is marked positive and negative. I don't know how well that's going to show up on camera. There it is, positive, and then this one's negative. This only has 3 connections, the 2 sets of wires that connect to it and this board, and then there's this little bracket. I want to test this before I put everything back together. I have an LCR meter. I went and got it. It does not go up to this range. This thing has a very large amount of capacitance in the tens of thousands of microfarads. I forgot what I said and I can't read the label from here. But my meter does not go up to that range. My meter only reads up to about 2,000 microfarads. So I can't really test it that way. Now I did see something online that indicates you can test whether the capacitor is kind of doing a thing by putting your meter in resistance mode and then testing the capacitor. And as you probe it, of course, we're passing electricity over this thing. And so you see the resistance increasing. Because obviously to measure resistance, we need electrical current across a resistance, a load of some sort. So we are charging the cap, and it is charging. So for now, with the tools I have, we're going to call the capacitor good. I have no other way to really test that capacitor. And the capacitor looks fine. It doesn't look like it had a catastrophic release of magic from inside. Now this board goes back on like this, and then we're going to screw our positive and negative leads on. Again, when you do this, make sure that you have these lined up correctly. The board is, and I don't know how well that's going to show up on the camera, but there's a plus sign here on this side, and make sure that it's synced up with the plus on the capacitor. Let me get leads put back on, and we'll go from there. So the next thing we're going to do here is plug it in. And what I'm going to do at that point is test some voltages on the back of the regulator board and see what those look like. We can compare those to the data sheet that we have with the schematic and make sure it's off. We are ready to kick the tire and light to fire, so to speak. No fire, no real fire. All right, so let's turn it on and see what we get. Okay, nothing's clicking. Let's see what kind of voltage we got. What do we got? We got nothing, so it's still not working. So at this point, I'm kind of stuck. I've replaced all these. I replaced the IC chip. I could check the voltages on the IC chip, but if I'm not getting output voltage, then something's wrong elsewhere. The voltage regulator board also contains the SCR, which is the crowbar. You know, I don't know if something else got smoked when I shorted this out yesterday. I replaced the pass transistor that I shorted. It went back to acting like it originally was. Since I've replaced everything else, it's not clicking this meter like it was. So I need to do some more debugging and research on this, I guess. You can buy replacement parts for pretty much all of this. The gauges, the switch, the fuse holder, the regulator board, the capacitor. This is the C5 filter capacitor back there. So I may look at that. Like I said, I don't really have a good way. You be careful. I don't have a good way to test that capacitor because I don't have a LCR meter that'll read that much capacitance. It was charging, so I'm going to assume it's good. I also will assume it's good because if we check the voltage while it's on, yeah, we're getting 23 volts out of that capacitor. I don't know if that's the correct value or not, but it is getting charged up, and I can tell you it takes a while for it to discharge if you don't do the resistor trick. The rectifier circuit on the bottom I have not tested. That's probably my next step, but that's going to require taking all this stuff out of the way again. The 2 rectifier diodes fasten in from the bottom, and then as you can see they're kind of bridged together. The other one's hiding right there, and then there's that one, and then these 3 heavy gauge wires connect them together in a full wave rectifier bridge. So the only way to test those that I'm aware of is to pull that whole thing out and disconnect it from the transformer. I don't think that I can test it in this thing. So I think that's going to be my next step. For now, it's still not working, but I assumed it was going to be a quick and easy fix, and so far It's eluding me. All right, guys, we didn't get anywhere. Sadly, my part swapping and tinkering around did not successfully conclude our mission. I think my next steps are to probably take that rectifier bridge out and test that. And then if that tests good, then I'm kind of out of airspeed and runway with this thing. And I'm probably just going to order a new regulator board and C5 capacitor from Astron. Those parts aren't super expensive. I would try to get a warranty repair, but I'm pretty sure Astron is going to say, you've been screwing around in here. We're not going to honor the warranty. And I can't blame them, right? Some random knucklehead on the internet probably screw things up. In any case, that's all I got on this particular video. Guys, thank you for watching. If you would give me a thumbs up, make sure you share the video with your friends. Subscribe to the channel. It'll make you happy. And you might possibly see me spark and let the smoke out of something. And make sure you ring the bell so you get notified whenever I post any new content. Thanks, y'all. Have a good one.